They're playing basketball
all around the world. To the beach, y'all. Let's go. All around the world. Y'all know this is so that. To the beach, y'all. Yeah.
Basketball is my favorite sport. I like the way they dribble up and down the court. I keep it so fresh on the microphone. I like no interruption when the game is on. I like slam dunk to take me to the hoop. My favorite play is the alley-oop. I like the pick and roll. I like the give and go. And it's basketball. Bow wow, let's go.
All around the world. Yeah, to the beach, y'all.
In my hands, ain't no telling what I'm gonna do with it. When I got possession, I'ma act a fool with it. I might cross you up and fake one way, turn around and hit you with the MJ fadeaway. I'm throwing down passes like J Kid, taking catch to the rack and I'm dunking on them like C-Mac. When I'm in the plane, I play with that Alonzo style. I'm like Darius, cause I can
shoot. Too many players get offers like me. Back and forth are likely.
It may not mean nothing to y'all, but understand nothing was done for me. So I don't plan on stopping at all. I want this forever mine, ever mine, ever mine. I'm shutting down in the mall and telling that girl she the one for me. And I ain't even planning the call. I want this forever mine, ever mine, ever mine.
Last name ever, first name greatest. Like a sprained ankle, boy, ain't nothing to play with. Started off local, but thanks to all the haters, I know G4 pilots on a first name basis. In your city, faded off the brown. Nino, she insists she got more class. We know, swimming in the money, come and find me. Nemo, if I was at the club, you know I balled. Chemo, dropped a mixtape that sounded like an album. Who'da thought a countrywide tour be the outcome? Labels want my name beside an X like Malcolm. Everybody got a deal.
Hey, what's up YouTubers? Mr. Hart, and today we are going to look at the substitution method. So myself, Mr. Gossam, and Ms. Garner are going to go over each type of problem. We've got kind of easier ones, kind of a medium level one, and then finish it up, we're going to look at maybe a harder problem that takes a little bit more algebra skills to solve. But first, we'll start it off pretty simple here. We've got 6x plus 9y equals negative 24, and 3y equals 6. Now, the substitution method, what the key is you want to try to figure out what one of the variables equal, and then use that and substitute it into the other equation to find whatever variable you have left to solve. So by looking at these two equations, this first one looks pretty complicated. It's kind of long. I've got my x and my y on the same side of the equal sign. That looks like a lot going on there. The second equation though, I have just 3y equals 6. So if I want to isolate the variable and get y by itself, I can divide by 3 and I'm left with y equals 2. So already, just by doing one step, I've got half of my answer. Because remember, whenever we have system of equations, we're trying to figure out where do two lines cross, where do they meet, what's our point of intersection. So now I'm going to take my y equals 2, and we're going to plug it into the other equation, the one that has x in, and whenever we substitute a number in for a variable, we want to take that variable out and put that number, put the value exactly where that variable was in that equation. So I want to keep the 6x plus 9, but instead of y, I'm going to put my 2. So parentheses 2 whenever we do substitution, and then equals negative 24. And now from here, we just want to solve from x using the algebra skills that we learned earlier in the year. We know that whenever we have a number on the outside of the parentheses, we want to multiply. We keep the 6x plus 18 equals, I still have my negative 24. Our goal is to get x by itself, so I see the positive 18 there. That's going to be the easiest thing to get rid of, the easiest thing to move. So to get rid of a positive 18, you want to take away 18 or a negative 18. These cross out. We have 6x equals. Now here we have a negative 24 and a minus 18. Instead of thinking of it as adding the numbers or subtracting the numbers, I like to think of it as just combining the two. So we've got 24 negatives and 18 negatives, so when we put them all together, they're all going to be negatives. So we're combining these values. So 24 plus 18 gives us negative 42. And now we just have one more step to get x by itself. We want to divide by 6. X equals negative 7. So when we write our final answer, because remember our goal is to figure out where do these two lines meet, our answer is x comma y. So we have negative 7, 2. That's our point of intersection. And now you know more.
Hey guys, Gossam here. So we're going to continue what Mr. Hart was talking about with systems of equations and substitution method. So he plugged in just a single number, y equals 2, and he continued that and found an answer. But what we're going to end up doing is we're going to actually plug in 2x. So instead of just a number, now we're starting to plug in a little bit more. So this is the medium problem. So what we're going to do, we notice that y is 2x. So if we notice that that's exactly what y is 2x, we're going to take 2x and plug it in where y is. So that looks like we have 3x plus 3 times what y is, which in this case is 2x equals negative 18. Okay, so that's the first step, is to be able to substitute in exactly what y equals. Y equals 2x, plug it in. So now we just have one variable, we have x, so we can solve for that variable. So we drop down our 3x, because nothing happens to it. Then 3 times 2x is 6x equals negative 18. Since 3x and 6x are on the same side, we can combine like terms. So we can say 3x plus 6x is a total of 9x's equals negative 18. Okay. The next step, we got to do the opposite. So if it's 9 times x, we got to undo it by dividing by 9. So we get x equals negative 2. Okay. So since we have x equals negative 2, now all we need is the y value. So if I look up here, I could plug it in the first one, but I notice we have a lot going on. It's a longer equation, and mathematicians, they usually want to do something that's a little easier. So if they can have an easier way, that's what they're going to do. So I'm going to look at the second one, and I need y. So if I have the x value, I can plug it in. So I'm going to plug that x value in to get y. So I have y equals 2 times, what did we get for x? Negative 2. So we get y equals negative 4. So at the end, how do we write this? Well, it's a coordinate point that we're trying to get. So x is negative 2 and y is negative 4. That's where these two lines intersect. So this is a one solution problem. And now you know more.
Hey guys, it's Miss Garner. I'm also going to use the substitution method to solve for a system, but this time we have a little bit more challenging of a problem that just requires a little bit more algebra skills. So I see this problem, and the first thing I notice is that I have an isolated variable. So I see that y is all by itself on one side of the equal sign, so I know I can substitute in for my y. So in this case, I'm going to take whatever y is equal to, 6x minus 11, and that's going to replace my y in my other equation. So just like substitution in a sports game, one player has to come in, one player has to go out. My 6x minus 11 is going to go in, and my y is going to come out. So this top equation, I can rewrite it as negative 2x minus 3. Make sure you have your parentheses, especially when you have a more complicated term being substituted in. So in our parentheses, we're going to have 6x minus 11. Close your parentheses, and then everything else is the same, so equals negative 7. So all we've done is our first equation is the exact same, except our y has been replaced with what's equal to it, which is 6x minus 11. Now that I have this equation, I see parentheses, so my first thought is I need to use the distributive property. So I need to multiply whatever's in front of the parentheses to every term inside of it. So my negative 3 is going to be multiplied to the 6x and also to the negative 11. The negative 2x, we haven't done anything to it yet, so it's just going to drop straight down. And then I have negative 3 times 6x is negative 18x. Negative 3 times negative 11 is a positive 33. And then equals negative 7 stays the same. Once I'm here, I'm going to draw a wall at my equal sign. And I see on the left-hand side I have 3 terms. Of these 3 terms, I can combine my 2 x terms. So my negative 2x minus 18x will combine to give you a negative 20x. Everything else we haven't touched, so we're just going to drop it straight down. And once you're here, we now want to try to isolate for our variable. So if we want to get our variable all by itself, you're going to take whatever is on the same side of the equal sign, and you have to move it. So this 33 has to be moved to the other side. So our inverse operation of addition is subtraction. So instead of plus 33, we want to do subtract 33. Whatever you do on one side, you have to do on the other to keep your equation balanced. So on the left, it's going to cancel out. So we're left with a negative 20x equals negative 7 minus 33 is a negative 40. Our last step, it's very similar to the first step that Mr. Hart showed you, which is if you have a number times a variable, in order to get that variable by itself, you want to divide. So we're going to divide both sides by that negative 20. That gives you a 1. So x equals negative 40 divided by negative 20. X equals 2. So at this point, I know my answer. The first part of my coordinate point has to be a 2. However, I'm still missing my y value. So I'm going to go back to my 2 equations, and I have to solve for y now. I see that my second equation already has y equals. So I'm going to use this equation just because it's easier to plug into, though either equation could work. So my second equation here, I'm just going to rewrite it, y equals 6x minus 11. I have an x variable in there. Remember, your variable is just standing for an unknown number, but in this case, we just figured out what x is. X is 2. So since it's not unknown anymore, I'm going to go ahead and I'm going to put a 2 in for my x. So y equals 6 times 2 minus 11. And now I can just simplify. So y equals 12 minus 11. So y equals 1. So my second part of my coordinate point, y is 1. My final answer is the point 2, 1, which is where our 2 linear equations, if we were to graph them, they would cross. And now you know more.